Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson I will explain three-dimensional trigonometry with the focus on the sine rule and double angles. This is lesson 3 of 5. Let's start. JM is a vertical tower and points K and L are in the same horizontal plane as point M, the foot of the tower. Angle MJL is equal to X. Angle KML is equal to 90 degrees plus X, and angle MKL is equal to 2x. JL is equal to 2 units. Number 1. Show that KL is equal to 1. Now, KL is this one over here. So this is what we are working towards. And remember, the way that you will approach this is you will make side ML the link between the two triangles, the subject of the formula. So we will start in the furthest triangle, which is triangle JML. Now, can you remember that I taught you the foot of a tower and the ground forms a right angle. So therefore you have a triangle JML, and that one is a right angled triangle. And this is where we will start. So we will start with in triangle JML. Remember, it's a right angle triangle. So the one that's working for us here, the ratio, will be sin of x, yx, because that's the given angle. And then sin's ratio is opposite over hypotenuse. And in terms of angle x, so therefore sin x, the opposite is side ML, the one you're looking for, over the hypotenuse is JL. Then we can substitute in JL's place the length. It was given that it's 2. And then we can make ML the subject of the formula, the link between the two triangles. So we will multiply the 2 away, both sides, and we end with ML is equal to 2 sin x. So now we have the link between the two triangles, and we can move over to triangle KML so that we can find KL. Now in that triangle, in triangle KLM, since it's not a right angle triangle, we can use the sine rule. And we can say KL over sin K angle ML is equal to ML over the sin of angle MKL. And then we can substitute. KL is the one we're looking for. Angle KML, this is this angle, this is the 90 plus X equals, and then ML, we calculated in the previous sum, was 2 sin X over, and then angle MKL is this one, and that one was 2x. Then in the next step we can do the following. This one, sin 90 degrees plus x, this is the reduction formula, but remember it's also a co-function, so we can reduce sin 90 degrees plus x to just cos x. Then in the next step, what I did was I got rid of cos x, so you multiply both sides by cos x. And then on the right hand side, the next thing that I can see here is sin 2x. That's a double angle. So there's only one option on the formula sheet, and I can write it as at the bottom 2 sin x cos x. And then cos x and cos x can cancel, sin x and sin x can cancel, 2 goes in itself once, 2 goes in itself once. Therefore, KL is equal to 1. Before we continue, have you subscribed yet? And a reminder, you can also visit my website onlinemaths.co.za. The link is in the comments below. There you will find all the chapters in the syllabus. Also feel free to leave a comment or like my video. Let's continue. So the next question says that we must show that mk is equal to cos 3x over cos x. So mk is the blue line over there. Now, first of all, we can start by saying in triangle KML, if we look at the angles there, we can say that angle KLM, which is this tiny little angle there, we can work it out by saying it's 180 degrees minus the sum of the other two. So therefore, it's 180 minus, and then you put inside a bracket the 2x, which is k's size, plus the 90 degrees plus x, which is m, and you reason angles of a triangle. And then in the next step, what you can do is you can multiply in the negative. So it's 180 degrees minus 2x minus 90 degrees minus x. Now we can add like terms. 180 minus 90 is 90 degrees, and minus 2x minus x is negative 3x. So now we know the size of angle KLM. We want to show that MK is equal to that horrible thing. So now we will go to triangle MKL, and we can write down the sine rule. So we can say that MK, and we make MK the subject of the formula, over the sin of angle KLM is equal to KL over the sin of angle KML. In the next step, at the denominator here, we calculated that angle KLM was 90 degrees minus 3x equals KL over, and then this angle KML was given that it's 90 degrees plus x. So in this one, there's two co-function reduction formulas. So we can say MK over this sin 90 degrees minus 3x, we can reduce it, and the name changes to cos 3x equals, and then KL in the previous sum we calculated was 1. We can write it down there, and then we can say the sin of 90 degrees plus x, that's a reduction formula, and that one we can reduce to cos x. And then for MK, we multiply the cos 3x away, and we end with MK is equal to cos 3x over cos x. In the next lesson, I will explain the area and sine rule as a typical exam question. Click on the video in the left-hand corner to take you straight to the next lesson.